There are several things in the F18A computers that are set to known states by the reset signal, which comes from the reset pin on the chip. There are separate things about the I/O that are set to known states based on that pin. We will discuss those things when we get around to talking about I/O. For the purposes of the computers, very few things are actually initialized. P is set to a strapped address that depends on what this node's function is. By default, each node is set to an execution address which identifies all of its communication ports for all of the adjacent nodes that are neighbors that might feed it code. That is the default. And we'll talk about how that works later when we talk about addressing and COM ports. For other nodes which have to execute code, for example boot nodes such as the SPI boot node, synchronous boot node, asynchronous boot node, one-wire quasi-synchronous boot node, any of these nodes that exist in that form, or the SERDES, have to execute some code after reset in order to be able to perform the booting functions. In that case, the starting address is again strapped appropriate to the entry point in ROM of those nodes where this would take place. For the purpose of the F18A computer, that address is hex AA, alpha alpha, and the beginning of every one of the boot nodes programs is at that address. Register B is initialized by reset to point to the I/O register. And the I/O register is initialized on reset as though the program had stored the hex value 15555 into it. What you read back will be different, as we'll see when we talk about the I/O register, but always remember reset is as though you had stored 15555. If you want to put I/O into the state that it would have been at reset, store that value into it and it will be there. Otherwise, the only initialization done in the F18A computer is to make sure that the stack pointers are initialized to a rational condition. Memory is specifically not altered by reset, and generally speaking, the contents of the stacks are not altered by reset. It is possible using tools such as the IDE to come by after resetting the machine and read the contents of the stacks, read the contents of memory, find out what is in register A. Basically, you can do almost anything except finding out exactly where P was at the time of reset and finding out what was in register B at that time.